All right, let's look at the homework 6.4, problem number 10. All right, so let's evaluate this improper integral. All right, so looks like this is not the kind with the infinitely long interval. It's there should be some infinite discontinuity, and we can see that when x equals 3, denominator becomes 0, so it's going to have a vertical asymptote there. All right, so what we can do is we're going to split this interval into, all right, first one is start from 0 and ends at 3. And the same integrands, 1 over quantity x minus 3 to the 4/3 power with respect to x. Then we're going to go from 3 to 8, 1 over, and we have x minus 3 to the 4/3 power dx. Alright, so we have two integrals, so I'm going to call the first one, say, I1, and the second one, I2. Alright, so let's work on I1 first. So I1 is equal to, alright, so the problematic up limit is the upper limit, so 3. So I'm going to replace that by b. Alright, so you have an integral from 0 to b, right? Then we have a limit as b approaches 3 from the negative side, right? And I don't like a fraction, so I'm going to write it as x minus 3 to the negative 4/3 power, right, dx. Right, so let's evaluate this, right? So I'm going to, let's see, find the antiderivative. So I'm going to take care of the limit later. So b approaches 3 from the negative side. Alright, so antiderivative is going to be add 1 to the power. So you have x minus 3, raise it to the, I add 1 to the power, so it's a negative 1/3. I divide by negative 1/3 is equivalent to multiply by negative 3. Right? And then you're going from 0 to b, right? So we have a constant, the negative 3, that's just going to be a number, so I'm going to put it right in front, and we're going to get negative 3, and we still have to take the limit as b approaches 3 from the negative side, from the left. Alright, so if you plug in b here, so you're going to get, let's see, I'm going to actually write it this way, 1 over, right? This is going to be a cube root, right? So it's a cube root of, right, b minus 3. Right? Then we're going to have a minus, and if you plug in 0, so it's going to be a cube 1 over cube root of negative 3. Right? So that's just going to be a number. All right, but what happens is here, if as b approaches 3, or from the negative side, so this guy approaches, let's say, so slightly less than 3, so it's going to be slightly negative, so it approaches 0 from the negative side, right? So then if you take the cube root of a small negative number, is going to be a still small negative number. So 1 over something close to 0 but negative is going to be, so this is going to approach, first guy is going to approach negative infinity, right? Negative infinity minus a finite number is still negative infinity, but you multiply by negative number, so it's going to make it positive infinity. So this guy is actually go to positive infinity. Alright, which means that this is divergent. Right? So we can answer the question here. Alright, so this integral diverges. Right? So if it diverges, we just have to spell diverges. Alright, let's check the answer. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.